Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 15 of our 30-day LeetCode challenge, and the problem which has been given to us today is product of array except self. We have solved this problem before, so this should be quick, but let's just go through the problem description. So we've been given an array nums of n integers where n is greater than 1, and we need to return an array output such that output I is equal to the product of all the elements of nums except for the number itself. All in all, if you look at the example, it's much more intuitive. So you've been given an example where you have an input as 1, 2, 3, 4, and basically what you want to do is you want to give out an output where your values inside your, or rather the elements inside your output array are going to be the product of all the other elements which are there inside the array except for the element which sort of corresponds to that guy. In other words, if you look at this guy, we don't consider 1. So the product would be 2 into 3 into 4, which is going to be 24. So that's over here. That's the first element. For the second element, you don't consider 2. So you multiply 1 with 3 and 4, so you get 12, and so on and so forth. So you've been given a few constraints over here, and you want to do this without using any division, and you want to do this in O of n. And when you sort of think about if this constraint wasn't given to us, this problem becomes really easy because all you need to do is then you just have to calculate the product and just keep on dividing that product with the element itself. So if you have the product over here, you would see that that's 24, and what you do is you do 24 divided by 1, 24 divided by 2, 24 divided by 3, and 24 divided by 4, and that's basically your output. But since we can't use that, the other approach that you can use is by actually using some extra space. And the ideology behind this thing is it's pretty straightforward. What you want to think about is if I can sort of simulate the same thing that we were trying to do with the products as well. So instead of just multiplying the entire product, how about we just multiply what's on the left versus what's on the right? Or if we want to talk about it, we can say that let's consider that we have an element over here, which is 2. So what if we multiply everything which is um, on the right of 2 and whatever is on the left of 2? And to do that in O of n, you can use extra space. And by using extra space, what you can do is you can calculate what's the um, cumulative product of as you go from left to right and also from right to left. And when you do that, what you would essentially have is when you look at element 2, you would basically have what's the cumulative product of whatever's after that versus whatever's before that. Whatever's before that is going to be represented in the left array, whatever's after that is going to be represented in the right array. And basically you're done. So let's just go ahead and try to code this thing out. So we'll start with the base condition, which is just going to be like, hey, if no numbers have been given to us, just return an empty list. And that's pretty straightforward. Now what we want to do is we want to create a left array and a right array. So let's just go ahead and do that. Let's just say left, and I'm just going to give 1 so that everything has a 1 value. And I'm just going to create the left array in such a way that the length is equivalent to the length of the nums that's been given to us. Same thing over here as well, and you can ignore the 1 because that's just like a placeholder for now. But essentially what we want to do is we want to like skip over to the next portion. So if you look at this example over here and you look at 1, well, the way you want to try to solve this problem is that if you just had all these values, you know that the value is going to be 24. So obviously that is going to be difficult to represent when you go from um, left to right because there's nothing over there. Basically, there's nothing on the left hand side of 1. But what you want to do is you can sort of hit this guy from going from right to left. So when you do that, you're going to have 4 into 3 into 2. And that's how we're going to like build out that area as well. And to skip over that, you don't use the same element. You're going to be calculating it with the next value, or the previous value rather. It's a little difficult to understand this when you're just trying to like explain it, but when you see the code, it's going to be a lot more easier for you to understand. So let's just go ahead and iterate from left to right first. So let me just add a comment over here saying that hey, we're going to do left to right, and essentially all the details that we're going to store is going to be residing inside left. So what we're going to do is we're going to do for I in range, and we're going to skip over the first value because, well, we want to look at the previous value before that to, understand what's the cumulative as you're sort of moving forward. So essentially what you want to do is you want to do left I equal to left I multiplied, or sorry, left I minus 1 multiplied by um, nums I minus 1. And I know that this can get a little difficult to understand, but let's just take a few examples. So let's say that you just had one array. That's the first condition. Well, in this case, the output is just going to be 1. So how do you sort of take care of that? Over here, it should not like enter the array because that should be, contained inside the left itself. So you're good over there. What if you had a value of 4? Or let's do 2 and 3. So we know that like the output that we want over here is basically going to be equal to, well, you've guessed it already, this is going to be 3 and this is going to be 2. And basically what you're doing is the output is going to be everything that you multiply with everything except for the element that sort of resides under the same index. But if you want to think about how you would construct the left value, then let's just have a look at that. So left is going to be pretty straightforward. If you sort of put a 1 over here at the beginning, well, essentially what happens is that when you multiply 1 with anything else, it's going to be the same value. So 1 into x is going to be equal to x, so you know that's going to happen. So you're going to have 1 over here, and left is going to basically, when you move or iterate to the next value, you can basically multiply whatever you had at the previous value with whatever you had inside your nums as the previous value and get that. So over here you'll have to, and the same thing sort of goes for the right as well. So I hope that sort of helps you understand a little bit more on how you would sort of want to go about like solving this problem. And I know it gets a little difficult, but this problem does have a lot of semblance with a few other algorithms which are already in place, um, like trapping rainwater would be one of the famous problems where you go left to right to understand what's the maximum so far, and then right to left. Obviously, you're not using cumulatives and so on and so forth over there, but the entire logic behind it sort of revolves around the same thing. So we'll try to do the same thing with right, but the only difference is going to be that you're going to write I plus 1 into nums I plus 1. So you're starting with the second last element, and you sort of check the last element, multiply that with whatever's there inside the right, that's basically 1. And then you sort of, you move from right to left, you have the right, and basically this helps you get the cumulative. Pretty straightforward. So if I do a quick print over here, it's going to be a lot more easier for you to understand like what exactly is happening. So do remember that the array that we had was 1, 2, 3, and 4. So as you can see over here, if you go left to right, you can see like everything that's been contained. So if you look at 1, there's nothing on the left, so that's just 1. You look at 2, only 1 is there, so 1 into 1 is just 1. If you look at 3, everything on the left is 2 into 1, which is 2. For 4, everything which is on the left is 3 into 2 into 1, which is 6. Same thing, you go from right to left. So you skip 4, you start with the third. So third has, the only thing it has on the right is 4, so you have 4 over here. Same thing as well for 2, you have 3 into 4, that's 12, and 1, which is 2 into 3 into 4, which is 24. And now all you need to do is you just need to multiply these guys with each other. So once you do that, you basically have the output that we want. And yeah, that's basically the entire code. So let's just go ahead and code that out. So let's just say left I into right I for I in range length of left. Yeah, and I think this should do it. So let's just go ahead and run this, and hopefully this should run fine. And awesome, you can see that's running fine. Let's go ahead and submit this. I'm assuming that's going to run fine as well. I should have removed the print, but yeah, doesn't really matter. So that's basically it. There's another way of like really optimizing the solution, and you can think about how to do that. But once you sort of get the intuition behind how to use the cumulatives, it becomes a lot more easier to use the optimal solution, in which you don't really need to worry about all these guys as well. But that was it for today's video. If there was something that you didn't understand, or if you had difficulty in understanding something, We already have another video which sort of goes into the depth of, helping you guys understand like how do you want to like tackle this problem. And I would sort of urge you to like look at it if you don't really understand my explanation in this video. But if you want to try solving this problem on your own, you can sort of look at the link given in the description below. And again, if you have any comments, if you have any suggestions, or if you have any doubts, just leave it in the comment section below and I'll try to respond to it as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We have discussion over here and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day.